Okay, let's get to our cognitive psychology topic for today, which will be the first part of language. And before we start with that, we have to go through a couple of definitions and go a little bit into the area of linguistics, actually, which is closely related in some areas, at least to cognitive psychology, as you will see in a moment. Okay, so let's start with some definitions. First of all, language. And language is something which is really unique to human. So the ways of communication which animals possess are really not language in the human sense. And you may know these examples where animals have learned a couple of words or maybe even to construct simple sentences, but that's not really a comparison to human language, to the flexibility and universality of that. And if you, in addition, think of how much or what an incredible effort it is to train, for instance, a monkey to use 20 words or something, and how easily children learn language, you see it's really qualitatively two different things which are going on here. So language is really the human capacity for acquiring and using complex systems of communication. And language is characterized, the human language, by a couple of features which make it unique. So one is that language uses arbitrary symbols. And these are basically the words we use. For instance, in English, you have the word tree to refer to this plant, big plant, which grows up. No idea what a good definition of a tree is. And in German, you have a different symbol for that, Baum, for instance. So the symbols are completely exchangeable from one language to the other. But within a language, you have a fixed symbol referring to abstract or concrete objects. Next, you have an hierarchical structure. So you build up, you start with the most easy sounds, you combine them in a pretty much infinite way to create numerous words. And these words can be combined in an infinite way to create numerous sentences, which are then more complex. And you could even go further and say, okay, the logic of sentences, the paragraphs, so text comprehension or things like that. So discourse analysis. So you have a hierarchical structure here from very basic units to very complex units. So that in the end, we can utter an infinite number of things. So we can express an infinite number of thoughts. And if you think about literature, how many different books there are and there will be, then you see that. And that's an example where it completely differs to some animal which learned a couple of words. They don't have all of these characteristics. Maybe some of them, but only then in a very limited scope. Okay, so what is linguistics then? And linguistics is basically the scientific study of language. And as such, it's a very broad field, and you can actually study linguistics by itself. And it has a couple of sub-areas. And some of them are more relevant for us psychologists, and some are less relevant. And the area probably most relevant for us is psycholinguistics, as the name already suggests. And in psycholinguistics, we are interested in the overlap between language and psychological things. So the definition is that it's the psychological and neurobiological factors that enable humans to acquire, use, comprehend, and produce language. Is that the neighboring room? Okay. So. Yeah, it's the other room. Okay, I was just thinking that something went wrong with the presentation here. Okay, so it's where comes psychology into the matter of language? So how do we learn it? How do we comprehend it, acquire it, and use it? So how can we generate meaningful sentences, or how do children learn that? Then we have two things where still is an overlap with psychology, but more with like social psychology. One is sociolinguistics, which investigates what the effect of society on the language is. And that may be, for instance, that new terms are created by, for instance, teenagers or other subcultures of society. And then we have a different term, sociology of language, where we investigate the effect the language may have on the society. For instance, by the availability of terms. And you may know that, for instance, that some terms change constantly. So, for instance, that 20 or 30 years ago, some types of children maybe have been classified as disabled, which are now slow learners or something like that. So the terminology changes to do that. And some languages may have such terms, others don't. Okay, so let's look at the different sub-areas of linguistics. There's first of all a big chunk which is theoretical linguistics, and that's what we look at here today. And then we have a lot of other types of linguistics, like descriptive, applied, or experimental, which we won't look at this today because that's not in the focus of like cognitive psychology and our understanding, which we want to have here. And theoretical linguistics looks basically at the theoretical structure of things. So how do we, can we describe language in a way? And we can sort the sub-areas on a gradient of complexity. And it all starts with the area of phonology, which deals basically with sounds. And we have two sub-areas. Sorry, not everybody may be able to see that, which is phonemics and phonetics. We'll speak about that in a moment. Then we have morphology, which deals with how words are constructed. Then we have syntax, how are sentences constructed by combining words. We have semantics, which is kind of a little bit independent of that. So how can we assign meaning to something, like in sentences or to words? And finally, there's something which is called pragmatics, where we deal with the thing how context may influence the meaning of the word, how we can use language to affect or influence the behavior of somebody else. And it can be instructions like, do you have the time? And so we ask another person to report the time back to us. And we will speak rather briefly about all these things to get a background on how language can be described and defined. Okay, let's start with phonology and the issue of different sounds. Okay, so in phonology we look at, or we have the idea that we have distinguishing sounds in a language. And there are some smallest elements in each language which can't be changed without changing the meaning of a word or of an utterance. So the definition really depends on meaning. You may have acoustically slightly different sounds, but if they convey the same meaning, then it's one phoneme. So that's a study of phonemics. And a phoneme is the most basic unit we have in a language. I think it becomes clear when we see an example. So in English, for instance, the letters or the phonemes R and L are two phonemes with a different meaning, because when you replace them, like in royal or loyal, you create words with a different meaning. In other languages, R and L, like in Japanese for instance, are not two different phonemes. That's the reason why people from that background have so much difficulty in distinguishing R and L and often confuse them. Because for them, they belong to one phoneme and are one category of meaning. While in English, they have two different meanings. So this is an example of the smallest unit of sound which can change the meaning of something. And you probably all have seen these phonemic charts, and they are not only about that they define how to voice and pronounce a letter or phoneme, but they describe all the different phonemes we have in English. And the number of phonemes available differ between languages, but always it's very roughly between 20 and 40 phonemes only. So in all languages, we only have 20 to 40 different most basic units which are used to construct the whole complex world of language, of then words, sentences, meaning, and so forth. And you can see that the phonemes do not always refer to letters. They're really about how they are pronounced, and when they are changed, that they actually make can make a difference in meaning. Okay, so the relationship between pronunciation and writing is often not direct. So for instance, we have the phoneme K, and in writing it can have been at least 3 different representations. We have cat where it's a C, we have kid where it's a K, and we have school where it's a CH combination. And that all maps onto the same phoneme. When you go into research with that, you become more trained after a while. And when you listen very carefully, then you may realize that these phonemes are actually pronounced slightly differently. So for instance, when you have cat and kid, it's called an aspirated phoneme. So when you hold your hand in front of your mouth, then you should feel a rather strong puff of air coming out when you speak the K. Maybe it's not because I'm not an English native speaker. For me, the demonstration doesn't work very well. Because when you do it in school or skill, they are called unaspirated, and you don't have such a puff of air, at least not that strong. So when you look at more detailed phonemics charts, you will see that they are slightly differently labeled. However, they both belong to the same phoneme. How could we test that? If you use like an auditory editing software and you replace the two, you swap them. So for instance, cat is artificially created with an unaspirated K. We still perceive it easily as cat. So there's no change in meaning, and therefore it belongs to one phoneme. So, however, if we would suddenly hear a different word, then we would actually have 2 different phonemes, which both sound like K, but ones are aspirated and ones are not aspirated. And in some languages you have that just the mode of aspiration makes the difference between, differentiates between 2 phonemes. Okay, so in phonemics, as I said, we investigate kind of the meaning behind the sounds. We look at what sounds bring about that we get a different meaning in the word. Now, when we look at phonetics as opposed to phonemics, so these are the 2 subcategories of phonology, then it's more about, let's say, the raw auditory signal. It's more about the sounds, about the physical characteristics of the sounds, properties of that. So we will see an example in the moment. So for instance, what is the fundamental frequency? What is the exact frequency contour, what we may observe when we analyze the sound? So it's about the physical production, the acoustic properties, the acoustic transmission, and the perception of the sounds of speech. That's what phonetics deals with. And sorry, in English we have a very, very wide variation of pronunciation, which makes it very difficult to learn the language. And there are some languages, like German for instance, where you have a very direct translation, for instance, from letters to sounds. And if you have a certain letter, it's virtually always pronounced in the same way, no matter where in the word it's placed. English, on the other hand, is very irregular in how it is produced. So, for instance, there is a very popular example. Who knows that example? Raise your hands. Okay, not too many. So how would you pronounce or speak that word? Yeah, so most people would say it was probably like when you apply the standard rules of English pronunciation, you would say goatee or something like that. However, people argued, well, you could speak that as fish. So how do you get to fish from that? Well, the GH could be pronounced as an F like in tough, where you have a GH in the end, which is spoken like F. The O, you have words like in women, which is, the O is pronounced like an I. So you have fi. And then the TI is pronounced as sh, like in nation. So when you apply like these rules, you could say, well, you could speak that as fish as well. I mean, this is just one example of the irregularities of the English language. The point is that you actually never would speak it like that, because these letters would, according to English rules, be never pronounced at that position in the word. So you will never find an English word where you have a GH in the beginning and you speak it like F. You may have it in the middle or at the end of a word where you speak it like an F, but not in the beginning. So in a way, it's just an illustration, but it's not a really valid point to make. But still, that can make it quite difficult for foreigners to learn English, this irregularity which we have here. Okay, so after having spoken about the phonology, the basic sounds we have, let's very briefly go to morphology, to words. And morphology is the study of word structure, the study of patterns of word formation. And the case is that we often have like a word stem and we create new words for that. And for us as lay people in linguistics, it may seem, well, whether I have word or the plural words, it's the same word. However, morphology deals with exactly like that. How do you change words for the meaning of context? So to give you an example, consider this sentence, the dog runs. You have three words, the, dog, and run, which bring about meaning. That's an article, then you have this animal, and then the way of moving. Now you have the dogs run. You could say you have the same basic words, but you have a different meaning in here. Here it's a single dog who's running, here it's multiple dogs which are running. So you changed the words, the basic words, you added something to that or took something away to change meaning. And this is what morphology is about. So in this example we have, which is called an affix, which is an addition to the basic word stem, and to change this, to create different forms of that. So when we have nouns, such as dog, when we add the S, what we do is we create the plural of the word, as you all are quite aware of. And in verbs, when we add the S, we restrict the object or the subject to the singular. It can only be one dog if there is an S attached to the word. So we are so aware of these rules that we actually never explicitly use them or become conscious of that. So generally an affix is like this as something which we add to that. It can be added in the front of the word as well. For instance, like undo something. Then we have the basic word of do, and we add the affix un to that. Okay, that's already everything I wanted to say about morphology, because that really is slightly more on the side of linguistics as compared to psychology. However, it is some important background information about that. Okay, syntax then deals with how do we construct sentences. There are rules to that. So what is this system of rules, how we are allowed to combine the words? And to give you an example, in the English, language, we have this general rule of that we start with the subject, then we have the verb, and then we have the object. So for instance, a correct sentence would be, the boy throws a stone. Incorrect would be, the boy a stone throws. In other languages, you may have different rules here. So this may be the correct order of words in another language. Okay, that's enough for syntax at the moment. It's just about how to construct sentences. Now let's get to semantics, the meaning of words. So that's the main purpose, what we are doing, why we are speaking, why we are communicating, because we want to express or convey some meaning. And the meaning is affected not only by words, but also by the syntax. So, and different words have, of course, different meanings, usually. And however, the meaning of an individual word may depend on the syntax. So, as an example, you may say, Peter's hair needs cutting badly, or Peter's hair badly needs cutting. So you have the word badly, and if I'm not wrong with my English, this means, not very meaningful maybe, that he needs a bad haircut, so that his hair looks horrible afterwards, and this means that he urgently needs a haircut. So you have a different way of meaning here. The relationship is quite complex between semantics and syntax, and you can easily create sentences which are syntactically totally correct but doesn't make any sense. So there is an example by Noam Chomsky, if you remember him from the first lecture. He had this colorless ideas sleep furiously. From the syntax point of view, it's a perfectly valid sentence, but it doesn't have any meaning. So, however, the boy throw a stone is a sentence which is syntactically wrong. It should be either the boy throws a stone, or it should be the past, the boy threw a stone. However, we know what people are talking about when we hear this sentence. So the meaning of the sentence is clear, although the grammar, the syntax is wrong. So for linguistics, that's quite a tricky job to find out at what point of syntactical mistakes does the meaning get lost, for instance. How much error or which type of errors are allowed to preserve the communication of meaning. Okay, and the last thing I want to speak about is pragmatics, and this is, so to say, with respect to hierarchy or complexity, the highest level. And pragmatics is about a little bit what we've seen before, but now more in the communicative aspect, the ways in which context contributes to meaning. And that is about that when we communicate to other people, that we often actually do not exactly specify what we need to know or what we want from the other person, but use very reduced information, but the other person knows and automatically infers. And in the textbook, there is an example where a person says, I've run out of fuel. And the other person just says, around the corner is a garage or a petrol station. So you automatically infer, or the persons automatically infer, he's run out of fuel, so probably he's looking for something. He didn't ask, do you know a place where I could buy fuel? He just said, I ran out. And the other person says, well, there is a petrol station around the corner, so you can buy fuel there. So there are a lot or an incredible amount of inferences we do all the time, and just by restricting the amount of information we say. So let's have another example of that. So you ask a friend, can you open the window for me? And suppose the person says, yes, I can, and does nothing. That would be a little bit weird, because usually when you ask somebody, can you open the window, you expect that this person actually opens the window. However, the context, a different context, may change the situation. So if the context is, it is a hot summer day, then probably that is the appropriate response of the second person. And this one would be a little bit weird or rude. However, suppose the window is broken and you struggle to open it, and you say, actually, in the sense of would you be able to open it? And then, yes, I can be a valid answer. There's no direct need, for instance, to open it at the moment. It's just then an information exchange. So the context really can depend on that. And you have to make these inferences. And that's what pragmatics is about. Another example is, do you have the time? And the usual response is to tell the person the time, and just saying, yes, I have the time, again, would be a weird or rude answer to that. So, if you want to be very correct or exact, the correct question would have been, could you please tell me what time it is right now? Or something like that. So, this is called implicatures. So that we imply things and the other person knows that exactly. And again, these implicatures differ between cultures and languages. So, for instance, and one thing which is very often happening, I know that only of Germans, for instance, if they go to the English way of living, can maybe England or the US, then here a normal greeting thing is, how are you? In Germany, that's not a greeting. If people ask you, how are you, they are actually interested in how you are. So you often see this situation when people come the first time to an English country, they are, how are you? Oh yeah, actually not too bad, I have a headache, but it's, you know, you get this reply and you see, okay. So the implicatures differ between countries. Of course, you learn after some time, so you just say, yeah, I'm fine, although you just ripped your leg off, and you just go on. What is the reason? Why do we have such a high level of implicatures? Because if you analyze everyday language, then you will see in virtually every statement you have that. And one reason for that is most likely that it makes language more efficient. And that we try to reduce the amount of communication required to exchange meaning and to exchange messages. We try to reduce that as much as possible. And if you think, then this is probably a good idea, because we still need to talk quite a lot to communicate meaning and messages. And if we had to make everything which is implied at the present state, if we would have to make everything explicit, then we could talk even more. Much more. Okay. So we spoke about linguistics, about language, phonology, up to pragmatics, and one term didn't really come up so far at the moment, and you may be wondering about why that is. And that is the term grammar. And the term grammar is a term which is very often used in the context of language. And the reason for that is that it kind of comes from a different terminology or nomenclature which doesn't totally fit in here. And you could say that grammar is kind of an overall term for phonology, morphology, and syntax. So in a way, it covers all these things. So in grammar, we refer to the set of rules which govern the composition of clauses, phrases, and words. So it encompasses everything. So the study of grammar includes what I just said, phonology, morphology, and syntax. And however, it can't exist in isolation in that. So it's often complemented by the other things which we spoke about, phonetics, semantics, and pragmatics. So grammar is kind of overall here. Okay, so to summarize, when you deal with linguistics, that means the study of language, you have a lot of sub-areas. And from a theoretical side, you can create this gradient of complexity. You start at the most basic sounds, and then you work yourself up, words, sentences, meanings, and finally the context in interaction between people, how that influences and forms your language. Well, that's as a summary of that. Okay, do you have any questions on this part of linguistics? Okay, then we do a little break now and continue afterwards with language. Okay, let's go on and let's talk very briefly about language development. And this, directly after birth, when children are born, then you may know that there is no real language. So it takes some time until that starts. At around 4 months of age, children can discriminate speech sounds. Now you may ask, okay, 4-month-old children, well, they are not really children, they are babies. How can you do experiments with them? Because they can't tell you, yes, I understood that, or can press one button or the other button or something like that. And one way to do that is, it looks a little bit weird, this apparature here, but actually what it is just a sucker where the baby can suck milk through this pipe. So it's like bottle feeding, basically. And what you find is that stimuli which are of interest result in an increase in sucking frequency. So what you can do, for instance, is present the same speech sound over and over again, and then change the speech sound. And if you presented the same sound over and over again, you will have the habituation. You may say, oh, new sound, so sucking increases slightly, then it fades down again. And when you now change the sound, and if it is a new sound to the baby, it will increase the frequency again. If it can't discriminate, it will be for the baby the same sound as before, and the frequency will stay the same. And that is one way how you can do experiments at that very early age already. In the visual domain, what you can use is the way where babies look actually. So if you present like 2 different patterns and one is more exciting than the other one, they tend to look into that direction, for instance. At the age of 4 months, they engage in babbling, just making sounds, and you already start to recognize like phonemes. They may do something like ba 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 da 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 or something like that. So they start developing some pre-verbal communication with that. And there is a transition stage where they already can communicate, and certain objects or things or activities may already have some sound, not really a word, some vocalizations or gestures or something like that. And then later on, when they acquire actually the language, then these pre-verbal forms are taken over by the proper words of that. So that's a very rough structure of how language develops, and that finds here. Now, the question is, what are the mechanisms how we learn a language and how we develop that? And you may remember our first lecture where in the history of cognitive psychology we said that B.F. Skinner, one of the strongest behaviorists with his experiments with the pigeons and the Skinner box and things, he wrote a book called Verbal Behavior in 1957, and he had this behaviorist approach to explain how language is acquired. And being a behaviorist, he says, well, it's learned by reinforcement. So when the infant produces something correct, a correct word, a correct sentence or something, the infant is rewarded in some way. The reward can be that the communication partner, like the parents, actually do understand what the child wants, or maybe rewarded in the sense of like, oh, that was well said, or something like that, or well done, or something. The criticism of that approach is that children actually don't care much about feedback. So they may say it wrongly, you may correct them, and they just don't care and continue saying it wrongly until at some point they suddenly start saying it correctly. So feedback doesn't seem to be really an important thing here. There are many, many more criticisms. And again, if you remember, the criticisms were brought forward, or one big criticizer was Noam Chomsky, who had this book review, where he really tore apart Skinner's approach. And Chomsky suggested something differently. He said, well, language is actually too complex to have just reinforcement in place as the only mechanism for learning. And what he said is, well, when you actually look at the situations where children learn, then the role models, like the parents or siblings, they themselves often use incorrect language. So only very few of us probably have the perfect, brilliant Oxford English or Queen's English, where there's no grammatical mistakes, no stopped sentences, false starts, things like that. And this argument has become known under the name of the poverty of the stimulus. So Chomsky argued that for children there is not enough information to learn language properly, but nevertheless they can speak and they learn it properly. So his solution to that was they actually don't need to learn grammar, it's inborn. So Chomsky said humans have an inborn, what he termed, universal grammar, which is an inborn knowledge of very fundamental rules of language which apply to all languages. So if you grow up in Africa or in Germany, Europe, US, whatever language it is, some basic set of rules is the same. Was his argument. So when you learn it, you only need to specify some parameters. So like, let's say the word order. You always have the rule that there is a word order which has to be adhered to, but what the exact word order is differs between languages. So by the way, this is how Chomsky looks more nowadays, so it's a more recent picture. And he had a very strong influence on linguistics and really formed that field quite strongly. However, it later turned out that some of his assumptions have been wrong. So for instance, this poverty of stimulus argument is not valid, because it has been shown that even if you have statements which are often individual statements which are incorrect, frequently, that overall you have enough correct statements, you have enough information in the language of the parents, of peers and so forth, to extract more in a statistical sense the correct underlying rules. So you don't need to have perfect speech to learn it and to find that out. And it has been shown that even in computer simulations, you can extract these underlying rules. So basically, there is no need for an inborn universal grammar. Okay, that only to give you a very brief idea about the issues and the difficulties when we want to investigate how language develops. That it's a very complex field and that there are very different approaches how to explain this phenomenon. But again, more detail would be beyond cognitive psychology as we treat it here. Okay, any questions on that? Okay, then let's go to the production of speech. Okay, this is like a flow chart of how we get from our ideas, which we want to express, to the actual vocal signal. And it basically all starts somewhere in the brain that we want to say something. So we have this neural activity, which then at some point becomes so concrete that we activate certain muscles in our body to produce the speech. We have our lungs, which have to move the air out here, and we have the vocal folds, which control kind of the source of the voice. Then we have the larynx, we have further the vocal tract as a whole thing, which is all used to shape, to create different shapes here. And the different shapes determine how the sound actually sounds in the end, what comes out of our mouth. So it's the way how the vocal folds work, it's the larynx, it's how we position our tongue, for instance, our mouth openings, all that determines the exact sound which is produced. So when we look at this in a little bit more detail, then we see that there are quite a few organs involved in the production of speech, and they are here. When we have the phonemes, as we have seen before the break, then they often are classified by two aspects of this articulation system. One is the place of articulation. That means when we have this airflow created by the lungs, where in the mouth is the airflow obstructed? And the other is the manner of articulation. For instance, how is the airflow? That means how is the airflow obstructed? So the where is, for instance, that you may put your tongue at the tip of the teeth or more to the top of the mouth, above here, to stop the air from flowing out. And how the airflow is obstructed is, for instance, this aspirated, non-aspirated. So the letters P and B differ mainly by the mode of aspiration. So how do you obstruct the airflow? By a sudden explosion of air or by a softer wear, for instance. Sorry. And then we have, which is called phonation or voicing, whether something is voiced or unvoiced. When it's voiced, our vocal folds are vibrating. If it's unvoiced, they are not vibrating. So we just press the air out and shape it then. And here's just an example of the different mouth positions, of course, kind of a prototypical way, to produce the different letters. So you can see that already the mouth opening makes a difference, the exact positioning of the tongue makes a difference. So there's a lot involved in how we produce the different sounds. And the sounds which are produced are often represented by spectrograms. And to understand them, I would like to do a very brief detour on Fourier transformation. You don't need to worry, and I would like to invite you to stay focused here. It won't be mathematical or anything. It's just about what's the basic idea. And these type of pictures, which we'll see in a moment, which are based on the Fourier transformation, will come up rather frequently in psychology and other domains as well. So the idea is that when we speak, we generate an auditory signal. And that can be expressed as an air wave. So you have some signal where you have a wave. So different going up and down. It's a little bit like a speaker. If you have a really large speaker, how it moves. When you have low frequency, it moves very slow. In a low frequency, if you have high frequencies, it moves much faster. So faster would be something like that, and low frequency would be something like that. When we then look at this signal, we may see, well, actually, we can decompose it. It's a combination of 3 different signals. It may be a very slow wave, a medium frequency, and a high frequency wave. And when we just sum that up, so for every point, we just calculate the sum of the 3, we get a signal like that. So this is, of course, a simplified example. Now, that's, let's say, our signal we pick up. And now we are interested, what are the components of that? And for that, we can use the Fourier transformation. Now, what we can do now is we can try to transform or bring that type of representation into a different representation where we actually denote what frequencies are in our signal. So along the x-axis, we do not have time anymore. Instead, what we have here is frequency. So this is a very low frequency, and this is a very high frequency. And this is the amount of energy of that frequency in our signal. So in this simple case, where we have a signal which is just consists of 3 signals, we have 3 peaks. So this one, lowest frequency, reflects this one, this, and this one, this. Suppose we would turn up the volume, let's say, of this lowest frequency. At your stereo, you turn up the bass knob. What happens is that the peaks go higher and the valleys go further down. In terms of the speaker, the membrane goes further out and further in. You get more stronger air waves. Here, in this representation, you would get a higher peak. So the height of the peak tells you how much energy is there, how strong is the signal. And you see there's no energy between these signals, so it's all 0, so to say. Now, when we put it into that representation, what we do have, we have these 3 signals along time, and we represent them in the frequency domain. Now, what we can do then is, when we want to do the whole thing back, we could say, okay, we have 3 frequencies of that energy, and then we could recreate that signal from that representation. So that's the idea how it works. So in a single graph, where we don't have time represented anymore, we could represent such an auditory signal. Okay, how do we get to a speech spectrogram? This is the waveform of a speech utterance. So these are the waves we have just seen, like a speaker movement going in and out. And this is the spectrogram. I will explain that. Now in this spectrogram, we again have time here. And for every point in the time, we determine how much energy is there in each frequency. So here we have frequency. This is 0 Hertz, and this is around 8 kilohertz. And now the amount of each frequency is shown by gray levels. So the darker, the more energy we have there. So in this example, you see where there is a word, there's much more energy here in the signal. And here you can already nicely see, we will see examples in the moment, that the energy is in certain frequency bands. So here we have time and here we have frequency. And we determine for every point in time what are the different frequencies present in our signal. Now this one makes it a little bit easier to read. It's a spectrogram again, but color-coded. So what has been dark is now red, and what has been bright in the other one is now blue-yellowish. And what we see is that in the letters we speak, or in our phonemes, one of the very characteristic features are the so-called formants. And the first formant, F0, is our baseline frequency. That determines our pitch of something. So when you have in particular vowels, you see that you can distinguish vowels simply by their formants. So just by seeing such a graph, you can see what formant it has been. And this is the first, or the baseline frequency. Then you have this formant, and you have this formant here. So this is F1, F2, and the exact way in which frequency they are and how they behave over time determines how a vowel sounds. There is specialist software for that to find these formants, but that can be quite tricky to determine. When you see that here, can be a very slight difference in amount of energy here. And if you miss one, you directly misattribute the different ones. So this is an example, again in this dark, bright representation, where the letter I has a very low F1 first formant and a higher second formant, and not very much energy between that. So this is 0 Hertz, 1000, 2000, 3000 Hertz. The letter U has a roughly comparable F1, but F2 is much lower. And then the letter R has a higher F1 and a very close F2 as well. So just by these F1, F2 relationships, you already can usually determine the formant which is used, or which is in the signal. Now these are spectrograms now of different words. So this is ball, bar, bow, and by. And you see that the formants have different contours across time here. So, and it has been shown actually, that is maybe a quite relevant information, that humans actually use that information for perception of speech. So if you use a computer software and modify the formant, you perceive a different vowel. And this is used for speech synthesis by computers as well. So you need that background knowledge to create artificial speech, for instance. So speech production is a very complex physiological process, as we have seen. So a lot of organs are involved in the vocal tract to shape that. And sounds are produced on a little bit coarser way of description by varying the place and the manner of articulation. Just by describing these two things, you can already describe most phonemes. And then we have seen these spectrograms, and in the course of the lecture we will see more of them. We can use these spectrograms to analyze and represent the speech signal. That's the primary way, if you are into the acoustics of speech, how to work with that signal. Okay, do you have any questions? Okay, then let's turn, I think, to our last topic for today, the perception of speech. this is what is called the speech chain. So we start with the things we just have spoken about, the production of speech. So we are on the side of the speaker still. We have the brain, we control via motor nerves some vocal tract, physiological level. Then we have the sound waves, the acoustical level. And then in the listener, we reach the ear, and then we have the whole physiological processing to actually have linguistic processing in the brain. So the sound waves arrive at the ear, we produce neural signals, we identify the phonemes and combine the phonemes into words. And that is actually an extremely complex task. And one example of that is that only since a very few years you have speech recognition systems in computers which actually work, like Apple's Siri or the Android apps for that. Before that, there was just not enough processing power, not enough sophisticated algorithms to make it really available on an everyday user basis. There have been speech recognition systems around for a longer time where you could, for instance, dictate something into a computer and write an email or something like that. Okay, and to understand why it is such a complex task, we first have to think about how much variation we actually have in our speech. So we have different accents, not only from foreign people, but also within a country. You often have to move only like 50 or 100 kilometers in a country, and people have a different accent. We have different pitches of voice, different speeds of speakers. There's so much variation in there. And it has been shown that, for instance, simply the word "the" has at least 50 different pronunciations. But our system is easily able to analyze that, and we just hear that and understand that. And one particular problem our perceptual system has is something which is called co-articulation. And that is that the phonemes are not articulated like as a neat sequence, like you have in letters, one after the other, but instead they overlap. And they do not only overlap, they interact with each other as well. So the pronunciation of one phoneme, depends on the previous and following phonemes. As an example, you have the phoneme N, and it's pronounced differently in 10 or in 10th. There's a slide when you look at the exact speech signal. The phoneme looks different. So for computers, a horribly complicated task to do, which our brain does so easily and automatically. This is an example where we have the phoneme S here, once in the word seat and once in the word suit. And you can see that the amount of energy here is slightly different, and that there is more energy in the lower band here and less energy in the upper band here, because what follows is different. Now, when we are on the level of phonemes, the next thing we want to try to create is find out which words have the person said. So when we identified the phonemes. And one of the big problems we have there is that in normal speech, we do not make breaks between words. It's fluent. If you look at the acoustical signal, there is no indication where are the word boundaries. So there are no pauses. This is an example, and this sentence is, there are no silences between words. This is like the normal waveform. This is a spectrogram. And in a moment I will show you can have an idea yourself where might be the boundaries between words here. And if you see where it is, actually the pauses often occur within words. and not between words in the acoustical signal. So it is there's a slight pause here, but the no and the S of silences is put together, and then there is virtually no energy, no signal here. And you see that from this point of view, it's virtually impossible to say, okay, yeah, here's a word boundary, here is one, here is one, here is one. Not possible that way. And to show that it is so difficult, and in addition to show that actually we use a lot of context to infer on words, there's a study by Pollack and Pickett, and what they did, they had rather good quality recordings of everyday speech of a conversation. And what they did is that they extracted either individual words or sequences of 7 words from that conversation. So in other words, you have context, and here you just have the word. And then participants just listened to that and were asked to reproduce. What did you hear? What did you say? And when they heard individual words, the recognition rate was only about 50%. While when they had a sequence of 7 words, recognition rate was around 90%. So they were much better if they had the context. Because if you only have an isolated word, it can sometimes be very hard to hear what it is. Often it can be very ambiguous. Okay, now I would like to, I hope the sound here works, usually it does, of an effect which is called the phonemic restoration effect. Because one problem which we have in our everyday language is that we have a lot of noise surrounding us. We have coughs, and we have car doors slamming. And when you look at the acoustical signal, you can see that such noise often completely overlays individual phonemes. However, a funny finding is that when we want to listen to that, we don't notice that. We think the phoneme is still there. So this has been put into a demonstration investigated in the 1970s. So you can just listen to that, hopefully.
Replaced by a higher amplitude extraneous noise such as the hum. Listeners generally hear the entire sentence as intact, even when they are told in advance that a portion of speech will be missing. You will now hear an example of this phonemic restoration effect. You will be presented with a sentence in which one phoneme has been removed and replaced by a comma. The sentence will be played 4 times. Try to identify the speech sound replaced by the comma. The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city.
Okay, what phoneme was missing? Did you hear that? The word was legislatures where the cough occurred. You would say the was missing. Any other opinions? Who thought the word sounded complete? Okay, let's have a look at the resolution.
Most listeners cannot tell that the unvoiced S sound in legislatures is missing from the sentence. Generally, all speech sounds appear to be present, and the cough does not seem to interfere with any of the speech, nor can it be located accurately within the sentence. You will now hear the sentence played with the cough replaced by silence. You should be able to locate the gap easily and determine that the S sound is missing. The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city. The state governors met with their respective legislatures convening in the capital city.
Okay, so what you just heard was basically the sound signal of the second example, but into the gap was just inserted a cuff. So it was not like that there was the S and the cuff was on top of that, but there was a gap in the signal, and the gap was just bridged by the cuff, so to say. However, it has been shown that it doesn't make a difference whether the S actually is there or not. People usually perceive the word as complete, although the signal is missing. So our brain automatically restores such missing items or missing things in our signal. And there's a nice demonstration that this is very strongly influenced by top-down. So, yeah, that's what I said. Yeah, there's something, we can skip that, visual in the visual domain, so that when you have these blobs or something, you can usually nicely read that. But if you just remove that and replace that with white, then it's very hard to read, actually. Okay, I wanted to go to the context. So there's a study where people heard a sentence which always started the same way, and here this phoneme was always replaced by a cuff. And as you see, depending on the context, always a different phoneme makes sense. So the question is now, what do the people hear? And it's exactly what matches the context. When you do it like that, almost all participants hear the wheel was on the axle, the heel was on the shoe, the meal was on the table, and the peel was on the orange. This red phoneme was always missing and covered by a cuff, just as we heard before. You use your context to infer on that. And that's the reason why when we only have a single word, it's very difficult for us to understand it comparatively. We may make a lot of mistakes, but when we get a context, it's much easier for us to understand. So why does it exist? Well, probably just to deal with the noise we have in our surrounding, with the fact that our signal virtually never has a good quality. And so that, yeah, we can just handle these inaccuracies. Okay. Now, I want to turn to another demonstration, which is called the McGurk effect. And that was described in the 1970s. And McGurk actually was a British psychologist while he was at the University of Surrey around the corner. And he was editing videos and combining videos with auditory material, and just made a mistake and observed something rather funny. And that is, you are allowed even to know that beforehand, you can't help it, that when your acoustical signal, what you hear is a baba, and you see a speaker who says gaga, what you actually hear is dada. So a third completely unrelated thing. Okay, let's have a video clip on that again. Well, this time a video clip. Maybe we can turn that a little bit off. Does it work? Yeah, to see that a little bit better. It's
watch this experiment.
Kind of a funny guy.
It's called the McGurk effect. What do you think he's saying? If you think he's saying da, 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 you are in a grand majority. But now, close your eyes and listen instead of watching. The voice is saying ba, ba, ba. Now, let's replay it without the sound. Yes, it's true. His lips are saying ga, ga, ga. So how is it that when the lips are saying ga, 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 and the sound says ba, 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 that our brains read da, da, da? The McGurk effect is an example of an auditory illusion. It's a great way to show that the accurate perception of information can involve the participation of more than one sensory system. In this case, vision with sound. We call it multimodal perception. The McGurk effect is a terrific example of the fact that the senses did not evolve in isolation from each other, but actually work together to help us perceive our world. When multiple senses are stimulated simultaneously, the brain begins to experience an information-rich learning experience and laps it up like ice cream. It encodes more information per unit time, and it remembers that information.
Okay, so this is pretty strong evidence for that when we understand speech, we actually do not only use the acoustical signal. Of course, the acoustical signal is sufficient in principle, but when we have additional information available, we use that, like vision. So when we had this diagram in the beginning, where we said, okay, we have this acoustical signal and it reaches the ear and we analyze it, we have to update that and say, well, we have acoustics and this is transmitted via the ear. However, we also have the facial movements which are picked up by our eyes and then are integrated. And when we have conflicting or interfering information, just as in this McGurk effect, then the brain tries to do the best out of that. And sometimes it's just that when you activate two representations, that in terms of our neural representation, you pick the middle one. And so you may get something completely new and and an illusion here in that example. Okay, so speech perception is multimodal, or can be multimodal, and can be influenced by that, to conclude that. Do you have any questions on that? Okay, then that's it for this week. Next week, we have the second part of language, where, among other things, we deal with of how to construct actual sentences and with syntax. Okay, see you next week. Thanks for coming.